Hey guys, this is Coach Lowe, and this is Contextual Geometry. We're looking at Chapter 9, Section 3, Similar Triangles. So we have some theorems and postulates that you'll need to write down, so anytime you need to pause this video, please do so. So 9.3, Similar Triangles. All right, so the symbol for similar or similarity is just one little wave. So we've seen congruent triangles. Now we're going to talk about similar triangles some more. We talked about similar figures. We know that similar polygons have to have all angles congruent or correspond, not all angles, but corresponding angles are congruent, and then corresponding sides are proportional. So today we're going to look at kind of something playing on that a little bit with triangles. So the first one is postulate 9.1, and this is angle-angle similarity. Angle-angle similarity says if two angles of one triangle are congruent to two corresponding angles of another triangle, then the triangles are similar. So if two angles of one triangle are congruent to two corresponding angles of another triangle, then the triangles are similar. I may have said congruent, I didn't mean that. Then the triangles are similar. All right, so this tells us that, okay, when two angles are congruent to two corresponding angles in another triangle, then we know more about that triangle. We know that the third angle is congruent, the third angles are congruent to each other, and we also know that corresponding sides are proportional, because that's what this means, right? Similar figures have corresponding angles congruent, corresponding sides proportional. All right. So let's say that we have triangle ABC. And triangle DEF. So this tells me angle A is congruent to angle D, and angle C is congruent to angle F. Then triangle ABC is similar to, now I have to make sure I went ABC, one mark, not marked, two marks. I want to do the same thing over here. One mark, not marked, two marks. We want to make sure that we have those corresponding angles and sides in the right spots, that they are corresponding in our writing just like they are on the picture. So triangle ABC is similar to triangle DEF. All right, theorem 9.2. Get another page here. Side, side, side similarity. If the measures of the sides of a triangle are proportional to the measures of the corresponding sides of another triangle, then the triangles are similar. All right, so if the measures of the sides of a triangle are proportional to the measures of corresponding sides of another triangle, then the triangles are similar. So if we are given two triangles, they could be kind of like the ones that we had before. It doesn't really matter. So I'll have a big triangle and we'll put a smaller one here. A, B, C, D, E, F. And they tell me that when I look at these ratios, that AB over DE is equal to BC over EF, and that is also equal to AC over DF. Now remember what this means. When I reduce these fractions, or when I look at the fractions, look at the numbers, they're all the same. So they reduce to the same number, the same scale factor. So if this is true, then the triangle is first triangle is similar to the second. So ABC is similar to triangle DEF. All right, and then the last one is side angle side similarity. So this is theorem 9.3. Side angle side similarity. If the measures of two sides of a triangle are proportional to the measures of two corresponding sides of another triangle and their included angles are congruent, then the triangles are similar. Now, these sound a lot like our triangle congruence theorems, congruency theorems, and they are like them, but these are for similarity, not congruency. All right, so here's what this one says. So if I have two sides, so if the measure of two sides are proportional, so AB over DE equals BC over DF, so AB over DE equals BC over EF, so they're proportional to each other, and the angle between them, the angles between them are congruent to each other, then the triangles are similar. So triangle ABC, and by the way, we could start that however we wanted, but once you start, that fixes it. So if I said BCA, I'd have to say EFD. All right, so if you need to back up this video to get that, since I didn't write it all the way out, you can definitely do that. All right, let's look at some examples real quick. All right, so let me see if I can get this moved down just a tad. There we go. All right, so we want to write this congruent statement, or this similarity statement. Triangle ABC. First of all, we need to check, is it angle congruent, or angle similarity, side similarity, or side similarity? So I see an angle and then I see two sides around it. So this could possibly be side angle side. So let's check to see if it is. Sides need to be proportional. So 6 over 12 has to be the same as 10 over 20. That reduces to 1/2. That reduces to 1/2. All right, so checking these sides are proportional, so we're good to go. This reduces to 1/2, and so does that one. Now we can check the angle between, and it shows that those are congruent. So this is side angle side similarity. So ABC, now let's just make sure we get the right one, because AB goes with ZY. So if we're going ABC, we need to go to ZYM. So make sure that you list those in the correct order. All right, so let's check out the next one. What do we have here? Do we have any angles? No, we don't. So it can't be angle. It can't be side angle, or a side angle side, but it could be side. So let's see how these are working together here. I'm noticing this is a smaller side and that's a smaller side. So ON should go with BA. All right, so let's see what that reduces to. 3 over 6 is 1/2, which means the rest of these should be 1/2, and they are. 4 over 8 is 1/2, 5 over 10 is 1/2. So I'm going to go ahead and mark these sides. ON with BA, and then MO with AY, because it'll help me when I have to write the triangle similarity right here. All right, so let's see where they started. They started at MNO. So look, red to blue to green. So we're going to do the same thing. We want to go red to blue to green. So I'm going to start here, red to blue to green. All right, so YBA. So hopefully that makes sense on how to name these. Let's grab one more and then we'll be through with this page. Let's just go ahead with this next one. It looks like angle similarity. So they start with single angle and then double and then nothing. So we need to do the same over here. Single angle, double, and nothing. So Z, Y, R. All right, let's check out the next ones. So on this one, we're supposed to find the value of the variable. So we need to figure out which sides match up, and then we can go from there. All right, so I see the angle, and actually I have side angle side, side angle side. Sides are proportional. I can see that because 24 over 12 and 14 over 7 is 2 over 1 for both of them. So that's my scale factor. If I go from the smaller one to the bigger one, it's twice as big. So maybe you already know what X is. I'm going to go ahead and set up a proportion. 2 is to 1 as 16 is to X. So cross multiplying there, 2x equals 16, or x is 8. And maybe you went the other way and said, hey, this little triangle is half of that one. So if this is 16, then half of that is 8. Perfect. All right, next one. We have angle-angle similarity here. And we could also probably use one of the sides, but we don't have two sides and an included angle on this one. So we'll use angle-angle similarity. And let's see if we can figure out what this side is. So this side matches this one. So 24 over 16. Now the way I knew that side matched up is it started with a right angle and then goes to the angle that's congruent. So this has to do the same thing. I can also use the hypotenuse, but I'm going to start with the leg here. So this leg matches with that leg, which means it says 24 over 16 is equal to 24 over x. So we know x is 16. Kind of a no-brainer, isn't it? All right, so let's look at the next one. Now we're trying to find the hypotenuse, right? The side that's opposite the right angle. So 24 over 16 equals 36 over y. Now 24 over 16, we can definitely reduce that because 8 will go into both of those, so that'd be 3 halves. So 3 halves equals 36 over y. Cross multiplying here, 3y equals 72, or y, 3 will go into 7 twice with 1 left over, and then 3 will go into 12 4 times. Y is 24. All right, so let's jump down and get this last one right here that's kind of pieced together. And see, go ahead and pause the video, see if you can figure this one out. All right, now that we're back, we need to match up sides. So I see that this leg goes with this one, and I see that this base goes with this base, and I see that this hypotenuse goes with that hypotenuse. All right, so let's pick out the numbers. The blues, they're not both numbers, but the reds are. So I have 30 over 20, or 3 halves, equals, and let's take the green first. So I took 30, so I've got to take 42 over y. So 3y equals 84, cross multiplying there. Or y is 3 goes into 84. 3 goes into 8 twice with 2 left over, and 3 goes into 24 8 times. All right, and then I'll use that same proportion here, 3 halves, is equal to, now let's take the blue, 30 over x. So 3x equals 60, or x is 20. All right, guys, hope that makes sense, and thank you for watching and listening, and I will see you guys in class. This is Coach Lowe, and I'm out.